done that, and we can see our grade on it. And we'll be able to see it once we submit that, we can do something.
Okay, go ahead and start on those, and then tonight I'll try to find out what's going on. I might just have to assign them all. Yeah, it's kind of a pain. Okay. Excuse me. Okay, so number 14. All right, so this one is pretty straightforward, so I'm not going to worry about the U substitution stuff, right? So first off, what's the derivative? Why is my stuff not working? What in the world happened here? Computer shut down. My tablet's not working. There it goes. Okay. So let's see. So what's the outside part? Cosecant. What's the derivative of cosecant?
Negative cosecant cotangent.
Okay, so it's negative cosecant theta squared cotangent theta squared, right?
On the test, is it okay if we use an X? Because it's the same.
Yeah, I'll try. I probably won't put thetas on there because I have to pull up special symbols and stuff.
Yeah. It's just easier.
Yeah. So that's the outside part. Now we have to take the derivative of the inside, which is the theta squared. So that gives us 2 theta. So we get f prime of x equals negative 2 theta cosecant theta squared cotangent theta squared. Okay, so because the inside part was so simple, I didn't do a U substitution. Okay, so the outside and then the inside, right? So remember when we're talking about this, when we take the outside, what in the world? What is going on here? Is everything on? Okay, where is this plugged in?
The black part might be.
You must have tripped over it or something. Yeah, I think that was the problem. Okay. Okay. All right, so let's look at number 15. Again, this is a pretty straightforward one. So let's go ahead and rewrite this. Y equals cosine of x to the 1/2. Okay. So the outside part is the cosine. So y prime equals negative sine. We're not changing the inside, so it's still square root of x, right? That's the outside part. Now we're going to take the derivative of the square root of x, or x to the 1/2. Okay. So, yes, all the co's are going to be negative. Anytime you take a derivative of a co.
I was thinking opposite.
Right. So, I'm going to rewrite this negative sine square root of x over 2 square root of x. And before you all ask, no, you do not have to do that. Okay. My panic-stricken geniuses.
Well, I did it that way, but if you like the whole 1/2 x to negative 1/2 it'd be negative 1/2 x to negative.
You can leave it like this if you want to.
Oh, okay.
No, you don't have to. No, it's not incorrect. It's just not clean looking.
I feel like these when I look back, I'm like, what did I do? But as I'm doing it, it's just not even
Yeah.
Okay, so this one, now I'm going to use my U substitution because it's sine squared, so this gets a little tricky. U, what's U going to equal? Pi theta. So du will be pi. Okay, so I'm going to rewrite this as 4 sine u. Remember, this is squared like that. It also makes the trig functions, it just seems to make more sense to write it with the parentheses squared instead of leaving that square right there. Just like it messes with your brain being there, okay? But when you move it and rewrite it like this, it seems to make more sense. Yes, sir.
How do you put like a sine squared into a calculator? Would you do it like sine?
It actually goes into the calculator like this. Right? So,
Like I tried putting it in to check on my test, like it was like it just came out like
oh,
error.
yeah, okay. So you have to do like sine x, and then you do squared. Let's see if that works. So we know what's the sine of 30 degrees. We know that, right? Let me just change this to degree. Sine of 30 degrees is 1/2, right? So if I do sine of 30 degrees squared, that should be 1/4. Everybody agree with that? Sine of 1/2. We know, sine, gee whiz, what am I doing? Sine of 30, we know is 1/2, right? So now if I do sine of 30 and I want it to be sine squared, I can just square this and it gives me 1/4. Okay, so you can just put it in like that. Yes.
I knew that you put a folder in for it, and I was like, oh, okay, she's putting a folder in for it, but I totally forgot to turn it in.
Turn it in.
Okay.
Oh, she just.
Okay.
Oh, she like just.
All right, so g prime of theta.
Okay.
So we're going to do the outside, so that's 8
Oh.
times the sine u. 2 minus 1 is 1, right? Times du. So this will equal 8 sine, and what's u? Pi theta times du, which is pi. So we get 8 pi sine pi. I made a mistake. I made a mistake.
Isn't it easy without doing the use?
Hold on. This is wrong. This is wrong.
I didn't use the use.
This is wrong. I'm sorry. I made a mistake. What did I not do?
Because you can't do it because you have to have the pi theta has to be broken down.
No, that's not what I did wrong.
You didn't take the derivative.
I didn't take the derivative of sine.
Yeah, so that's.
Okay. So let's see. 8 sine u, that's the outside, right? Times the derivative of sine, which is cosine u du.
Wait, wasn't it wrong because you made u the pi theta instead of the sine?
No.
I
You could do it that way also, but I
That's
did
why
it.
did
You just,
That's why it's throwing me off.
yeah, that's okay. That's okay.
Signs on the inside.
When you rewrite it like this, instead of this, it makes it more clear that sine's on the inside. That's you.
Sign u.
Sine u, right.
Okay.
Sine u. Okay, so let's see. We did that. We did the, okay. So now we get 8. We're going to substitute our u back in. So this will be 8 times the sine of pi theta times the cosine of pi theta times pi. Is that what we got here? Yes. So we have 8 pi sine pi theta cosine pi theta. Okay. Yes.
Like sine and cosine, it doesn't matter what order.
Doesn't matter because it's multiplication. Right. Okay, 17. Now it gets trickier. Yes, ma'am.
If you were to do inside outside for 16, how would you?
So if I look at it as 4 sine pi theta squared, right? So that'd be 8 sine pi theta, right? Times the derivative of sine pi theta.
Oh, I had the sign on the outside.
Yeah. So when you take the derivative of this is you have to do inside, outside again.
Yeah.
Okay. Okay, so this one you really need to use the u substitution. So what's our u going to be? Oh, I was going to make u cosine 3x squared. Because then I can write this as y equals sine u. Okay. Du, now we've got to do outside, inside, right? Remember this is, it's just the x squared, right? So this is negative sine 3x squared times the derivative of 3x squared, which is 6x. So I get negative 6x sine 3x squared. That's my du. Okay. So y prime will be equal to cosine u, cosine u times du. Right? Outside, the outside is taking the derivative of sine, and that is the cosine. The inside is the derivative of cosine 3x squared, and that's what du is. Okay, let me say that again, because I know some of you were taking notes. Right? The outside of the original problem, if I did not do u substitution, okay, the outside is the sine. Derivative of sine is cosine. The inside is this part, and that's my du. Okay. Okay, so we have y prime equals cosine of cosine 3x squared times du, which is negative 6x sine 3x squared. So we get negative 6x cosine of cosine 3x squared times sine of just 3x squared. Yes, Ben.
Is it okay if I kept the negative with the sign and I didn't move it with the 6x?
Yes, just be very careful. I typically don't like to leave the negatives here because it ends up looking like we're subtracting. So that's why I like to move that negative out in front. Okay? Okay, let's move on. Let's look at number 18. Find the equation of the tangent line at the point. I'm going to give you a couple minutes to do it yourself, and then we'll do it together. All right, so what do we need to figure out in order to find the equation of the tangent line?
Derivative.
The derivative, which gives me the slope of the tangent line. So I have a point. I need a point and a slope. I have a point. Now I have to find the slope. So I'm going to rewrite y as x squared plus 3x plus 6 to the 1/2. So y prime, okay, this one I'm just going to do outside, inside. 1/2 x squared plus 3x plus 6 to the negative 1/2. That's the outside. And then the inside will be 2x plus 3. Okay, now I'm going to evaluate this at x equals 2. Okay, so that gives me 1/2 times 4 plus 6 plus 6 to the negative 1/2 times 4 plus 3, right, which gives me 1/2 times 16 to the negative 1/2 times 7, which gives us 7 over 2 times the square root of 16, which is 7 over 2 times 4, so it's 7 over 8. That's my slope. Did everybody get that far? Okay, now we're ready to go ahead and write that in equation form. Y equals m, x minus x1 plus y1. So y equals 7 over 8, x minus 2 plus 4, and we're done. How'd we do? Caitlin?
-1/2 on 16.
Because when I subtract 1 from this exponent, I get -1/2.
No, like,
10 plus 6 is
okay, I see.
16.
Yeah, I see.
Miss Murray, I'm absolutely brain funny. How do you get to 2x plus 3? On the right.
We did the outside and then the inside. The derivative of the inside is 2x plus 3. Okay? Any other questions? Okay, let's do number 19 together. So I need a slope. Okay, I have a point. So same thing, we can do outside, inside again. So y prime equals 2 times x squared plus x minus 2 to the first times the derivative of the inside, 2x plus 1. We're going to evaluate this at x equals -1. Notice I'm not worrying about simplifying it and stuff, right? Because I'm just going to plug in the value of x now. So y prime, which is my slope, is equal to 2 times 1 plus -1 minus 2 times -2 plus 1. All I did was substitute x equals -1 in there. So that's going to give me 2 times -2 times -1, which gives me a positive 4. There's my slope. Okay, so y equals 4 times x plus 1 plus 4. And we're done. Okay. So one of the things that I worry about with you guys with your AP exam is that you psych yourselves out. You look at questions like this and you're like, oh, I don't know it. But you do. You know how to do this. Okay. Use the knowledge that you have. Just keep moving forward. Constantly be doing something. Okay. Constantly write something down. Okay, number 20. Oh, now we got trig. Oh, no. Okay, you want outside, inside, or U sub? U sub?
Yeah,
What would U equal? 2x. Okay, so du is 2 dx, right? Okay. So y is equal to sine u. Y prime, what are we going to do? Did I start the recording? Yeah. Okay, cosine u times the derivative of u. So that gives me cosine of 2x times 2. So y prime equals 2 cosine 2x. We're going to evaluate this at x equals pi over 3. Faith, do you have a question?
I just was trying to write it down, so I was just curious. I asked you to answer this. Oh my god, I'm sorry. 19 months. I didn't see the full name. Yeah, thank you. Sorry.
Okay, so we took the derivative. Now we have to substitute in pi over 3. Because we're still looking for our slope. So y prime, which is our slope, will be equal to 2 cosine of 2 times pi over 3. So go back to our unit circle where this is going to be 2 cosine of 2 pi over 3, right? Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 right here. That's 2 pi over 3. The coordinates here are -1/2 square root of 3 over 2. So we get 2 times cosine is the x value, so that's negative 1/2. So we get negative 1 as my slope. Right? Okay, going back, now we've got to put it in the equation. Y equals negative 1 x minus pi over 3 plus square root of 3 over 2. Unless otherwise asked to, leave it in that form.
How would you change it? If they,
You could distribute, if it was asking for it in slope-intercept form,
I thought they meant like changing the pi over 3.
no.
It's not that it's hard, Miss Bernie. There's so many things you could mess up,
Yes, very true.
and like it's kind of hard to like get started without like getting off on the wrong foot.
Yes, so you're going to do 21 by yourself.
Sounds good.
Okay, so what method did you use? Really? Okay.
That's the same
Because
thing as
I don't know how to
the
do you with that.
Yeah, without the substitution.
Okay.
I don't understand the difference between the two. So
Neither do I.
to me, they're the same.
There isn't a difference. It's just to separate kind of
Yeah. So you don't.
And I don't know how to think like that.
Whenever they say the easier ones, like the one before, I use both.
This is actually an easy one because you would be using a 1/3. I'm sorry.
Yeah, that's
And
gross.
it would be.
You're right.
Like the you do 1/3. Sorry.
Okay, so we're going to do 1/3. 9 minus x squared, right? That's the inside. We leave it alone for now. Subtract 1 from the 1/3, so negative 2/3. So there's our outside. Now we're going to do the derivative of the inside, which is negative 2x. Yes, ma'am. Oh. Okay. Okay, so y prime equals negative 2/3 x times 9 minus x squared to the negative 2/3. We're going to do this at x equals 1. Okay.
Can you just multiply with the top equation? Just like plug it in.
Yep.
Oh, I don't
That's
know.
what I just.
Okay. So you don't have to. You can substitute it in here instead. Okay. So we get negative 2/3 times 9 minus 1 to the negative 2/3. Now you can use your calculator. Right? Negative 2/3 times 8 to the negative 2/3. Okay. Which should be 2 to the negative second or 1/4. Let's just double check that though. Right? 8 to the power of negative 2/3. 1/4. Okay, so this is negative 2/3 times 1/4, which equals negative 2/12, which is negative 1/6. One of the dangers with these problems is you do all this work and you haven't even gotten to the answer yet. Like this is something that we need in order to get to the answer. So this is my slope. So y equals m x minus x1 plus y1. Okay. So remember, you always want to go back and read the question, right? So y equals negative 1/6 x minus 1 plus 2. Boom, we're done.
bang.
Okay. Question?
It's just like there's like a table of this stuff. Just come out of this.
Oh, that's why it works. Got that.
Where's 21? Oh, we can-
Where are those?
All the way at the bottom.
No, we won't get there.
Okay, yeah, I know.
But we will get to e to the x times sine squared.
We're doing that next.
That's where we're going.
Yeah, no, I saw that.
Okay.
Beautiful. This will be either the U.
Want a brain break?
Yeah, I do.
Okay, just like 3 minutes.
Can I go to sip of water?
Yes. And Kaylin, you can go to bed.
It's so harsh.
This one, I was saying outside, inside, but it wasn't the same because you didn't get that. It's 3 and 4.
cosine 2x. I didn't get that?
Well, you have like, see, you have cosine
Did?
2.
Sure.
You have 2 theta over not theta, 2 pi
Look right here.
over 3.
2 cosine 2x.
Is there more to derivatives than this? Like how much farther to derivatives?
So then I substituted in the pi over 3, so 2 cosine 2 pi over 3.
Well, yeah, this is basically.
Oh, you forgot the 2 here.
Oh, okay, thank you. So I was like,
Yeah.
Okay.
Like, yep, I got the same answer.
Yeah, I'm not even appreciated. Just get headshots.
You guys had a leak in our roof. So I had to go up on the roof yesterday to go find like what was wrong. Well, I had to go to the attic first. We had to kind of do all of our house like in the attic. And that's I had to go on the roof. And then mom said, "Mom, the gutters." And our house like is the roof.
It's a lot of gutters, right?
There's so many gutters and there's so many trees. So I walk around the house a little lower and I get to the back and like the screen, so everything just slides down the screen and they're just full. So I had to go down like grab it out, put it in a bag.
I can't do that
Everything is
because
just
there's
so
like
absorbed.
there's usually bugs in there.
It's surprising they're not
Yeah,
that
no.
bad.
Like if a
Can't do
I
lizard
did
jumped
get a
out on
nice-
my face, I would literally
Yeah, but
fall
there's
off
usually
the
other
roof.
bugs too
Yeah.
in Florida.
I put gloves on.
Like I want to vomit just hearing about it.
Yeah, I
You're
got.
telling me, and I'm picturing. I'm like,
Yeah, I worked from 7.
Imagine he just fell through the attic and leaked the room.
yeah, I can't clean our gutters out.
Donnie,
falling to
so
the
Donnie
attic.
walked up into the attic and stepped and missed the like the
Joist?
the joist, and then
Yeah.
hit the ceiling, but didn't like put it too much pressure. But it knocked all our fishing rods off, and they whacked my mom in the head. She was like, "I was just trying to sweep." Like, we have them right above the garage door. She was out there.
Okay, let's get back to work. All right, let's get back. Oh, I had the video going the whole time. Okay.
Now you're gonna hear my stories.
Yeah. Okay, so number 22, we're just being asked to find the derivative. Okay, so let's just step through this. H prime of x. This is, what is this? A product rule, right?
Yes.
First times the derivative of the second plus the second times the derivative of the first.
What kinds of things that like would they use this for? Like, you know, I don't know. Just think about it.
So this is another one of those things where we're just learning some skills,
Yeah.
but then these would be used when calculating things like velocity or acceleration, things like that.
So something I'll never got.
So we are learning these skills. Yes.
Could you change sine 2x
To sine squared x. Yes, let's do that. So this is, well, you know what I'm going to do? I'm going to work over here to find the derivative of sine squared x, because I find that sometimes it's easier to just work with it separately. So we're looking at the derivative of sine x squared, like that. That makes so much more sense to look at it like that, doesn't it?
Sure.
Derivative of sine x. Yeah, so now we can do the inside outside. So, or outside inside. So outside is 2 sine x, and then we subtract 1 from the exponent, so we just get 1. That's the outside. Now the inside, what's that? Cosine x. See, it looks so much harder when it's written as sine squared x. When you change it to sine x squared, all of a sudden that whole outside inside side becomes more obvious. Okay? Okay, so let's go back over here. We've got e to the x times 2 sine x cosine x plus sine squared x times the derivative of e to the x. Well, what's the derivative of e to the x? E to the x of x, which is 1. So we have, which I'm just going to clean this up a little bit. 2e to the x sine x cosine x plus e to the x sine squared x. And we're done. Now, let me just tell you that a lot of times on your AP exam, this type of question would be a multiple choice question. And what they're going to do, because they're nasty old cranky ladies, or cranky men, I don't know, but they're old cranky people, right? In the multiple choice, they're probably going to factor that e to the x out. And they're going to give you the answer like this. In fact, they're probably going to make it even worse. They're going to do this. They're going to factor out e to the x and sine x. And they're going to give you your answer as 2 cosine x plus sine x. They're going to write your answer like that. Okay? But it's a multiple choice question, so you should be able to figure out that they're the same. Yes, Ben.
Oh, why can't you move the other e with the first e? Or e to the x, sorry. So there's like the plus e to the x. Why can't you move that with the 2 e to the x?
You're talking about right here?
Yeah.
They're not like terms because this is e to the x sine x cosine x. This is e to the x sine squared x. Okay. Numero 23.
She's bilingual.
It's all those things
Good
that
thing
you're
I'm
hearing
working
from there.
Okay. So this is a product rule again.
Yay.
Right? F prime of x. The first times the derivative of the second plus the second times the derivative of the first. Okay. All right, first part's easy. What's the derivative of cosine? Negative sine. So we have negative natural log of x to the third times sine x. That part we're good with. Okay. Now we need to work with this whole derivative of natural log of x to the third. Okay. U sub or outside inside? The U sub? U sub is kind of what I was thinking too. Okay, so I'm going to say u equals x to the third. So du equals 3x squared. So rewriting this, we're going to do the derivative of the natural log of u. What's the derivative of the natural log of u? So it's 1 over u du. Okay. So u is x cubed. That's my phone. So this is 1 over x cubed times 3x squared. So we get 3x squared over x cubed. Double check our work here. So I made that 3x squared. X cubed. So the natural log of u, the derivative of the natural log of u is 1 over u. The derivative of the natural log of u is 1 over u times du. U is x to the third, so it's 1 over x to the third. Du is 3x squared, so times 3x squared. Now we're going to go ahead and simplify this. This is 3 over x. Okay.
I don't really get why. Wait, what's your u is x to the third? It's not natural log of x to the third.
Correct.
So you're trying to find the derivative.
So when you do u substitution, you want the inside part to be your u.
Yeah.
Okay.
Just blanked out for like 1 second and missed like all of it.
Yeah.
Wait.
Can't do that. Can't go off time for that.
No, I don't know where.
Okay. So now that was all to find
You get 100 on the test.
right here, the derivative of the natural log of x to the third. So we've got This is plus cosine x times 3 over x.
Now, do you have to simplify the 3x squared over x cubed?
You probably should, yeah.
Honestly, it makes it easy.
So I'm just going to rewrite this negative natural log x cubed sine x. I'm going to put that in parentheses. That's kind of weird, isn't it?
Does it matter what order you put all that in? Like this.
You should always put the constants, or you put the constants in front, and then you should put the variables in front of the trigonometric.
So trigonometric values go last.
Is that it?
Yeah. Yeah, usually. It's not that important. It's not that important. Don't worry about it. And that's your answer.
Can you put cosine x over?
You can do 3 cosine x over x, yes. Just be careful. Don't cancel those x's out. Okay.
I would.
All right. So notice how I wrote it all out, though, to try to avoid the confusion, right? Wrote it all out, and then I worked with any derivatives that are a little complex, I work with them completely separately. Okay. Okay. It's a very good thing I'm a math teacher.
I'm fairly English on that.
You are not gonna let me.
Okay. Okay. So this one, you sub or outside inside?
Always outside.
Outside, inside.
Outside, inside? Okay.
No, no.
Okay. I'll do it both ways. This one's a pretty easy one. G prime of x equals. Okay. What's the derivative of the natural log of something? 1 over. So it's 1 over what? X cubed minus 2x times the derivative of x cubed minus 2x. So we get 1 over x cubed minus 2x times 3x squared minus 2. That gives us 3x squared minus 2 over x cubed minus 2x. Now, when you have problems like this, if something reduces, you should reduce it. For instance, let's just pretend that there was an x here. If that happens, we should factor it out and reduce. Okay, so you should do that. Okay, in this particular case, we can't, but I just want you to be aware that you should reduce it if possible. Okay.
We're good. I got
Yes, we're going to do one more problem. Una más. Look at that. See that? Mucho español. I actually had 6 years of Spanish. Can you believe it?
and math. Can you teach math and Spanish?
6 years of Spanish, but that was like 40 years ago. No exaggeration.
I bet you were asking the same thing Carson does. How am I going to use this?
Oh no, I know. I lived and worked in South Jersey. You had to have Spanish. Okay, let's do 27.
Okay.
Sine x cosine x. I'm going to change it to the 1/2. Okay, so I'm going to do outside inside. F prime of x. Now the outside 1/2. Don't touch anything that's inside. To the negative 1/2. That's the outside. Times the inside, so derivative of sine x cosine x. Okay, outside, inside. So now I'm going to work off to the side to figure out the derivative of sine x cosine x, because this is a product rule. First times the derivative of the second plus the second times the derivative of the first. What's the derivative of cosine?
Negative sign.
Negative sine. And the derivative of sine is cosine.
So because you're subtracting.
So negative sine squared x plus cosine squared x. Okay. So we have 1 over 2 square root of sine x cosine x times negative sine squared x cosine squared x. So I'm going to just combine that. Negative sine squared x cosine squared, plus cosine squared x, sorry. Plus cosine squared x plus. And we're done.
Oh.
Now, here's my question. What if this was a positive sine squared x plus cosine squared x? That equals 1, right? So if that's a positive, then you should be changing it to 1 over 2 square root of sine x cosine x.
I hate trig.
It's just rules. It's not that it's hard math.
Okay, we will stop there. You do have a quiz tomorrow, or test tomorrow, actually. Test tomorrow. Yes, on Wednesday.
I'm getting an idea.
Okay, that's your answer.
Oh yeah, we're not ready. Yeah.
There's no way.
What was it?
Yes.